Good evening. We have breaking news from 93 million miles away. The Sun has reached a fever pitch of activity as it flips its magnetic field, marking the official arrival of the solar maximum. In a dramatic development, the Sun's north and south magnetic poles are swapping places, a reversal that happens roughly every 11 years. That's like Earth's north and south poles trading places every decade, an almost hard to imagine flip. Welcome to Space Observing Stations, the channel that takes you beyond the boundaries of Earth to discover the wonders of the universe. Get ready for a one-of-a-kind experience, from the latest scientific discoveries to the most fascinating mysteries of space travel. Are you ready to explore the unknown? Fasten your seatbelts. The pole reversal on the Sun signals that our star has entered its most active and stormy phase, and it's happening right now. Why is this urgent? Because an active Sun can send solar storms our way that disrupt satellites, power grids, and radio communications here on Earth. Over the next year or so, we'll be under the Sun's highest bombardment of solar flares and charged particles. Tonight, we'll break down what the Sun's magnetic field flip means, how solar cycles work, and what real-world consequences we can expect, from dazzling auroras to potential tech blackouts. Most importantly, could a superstorm like the Carrington event happen again? Let's get into it. The Sun is not a solid object like Earth. Instead, it's a seething ball of plasma, constantly shifting and churning with intense magnetic activity. Every 11 years, the Sun reaches a critical point where its magnetic poles completely reverse. Right now, we are at that peak, a period known as the solar maximum. This event is not random. It's part of the Sun's natural behavior. Since astronomers first tracked sunspots in the 1700s, we've learned that the Sun follows an 11-year cycle where its activity rises and falls. Scientists predicted that solar cycle 25, which began in 2019, would peak in 2024 or 2025, and here we are, right on schedule. During a solar maximum, the Sun transforms into a more chaotic and violent star. It becomes covered in dark, cooler areas known as sunspots. These are not just surface blemishes. They are sources of extreme magnetic activity, launching enormous bursts of solar flares and coronal mass ejections, CMEs. These violent outbursts send enormous amounts of radiation and charged particles streaming through space, sometimes directly toward Earth. Although the Sun goes through these cycles regularly, each maximum is slightly different. Some are mild, while others unleash unprecedented storms. Scientists have been watching solar cycle 25 closely because its activity levels have already exceeded expectations, producing more sunspots and flares than initially predicted. What does this mean? It means Earth is entering a period of increased space weather risks that could impact technology, infrastructure, and even everyday life in ways we're only beginning to understand. The Sun's activity doesn't just stay in space. It has direct consequences for Earth, affecting everything from power grids to aviation. One of the most significant threats is geomagnetic storms, disturbances caused when solar particles interact with Earth's magnetic field. A strong enough storm can induce electric currents in power grids, overloading transformers and causing widespread blackouts. This has happened before. In March 1989, a massive solar storm knocked out Quebec's entire power grid, leaving 6 million people without electricity for 9 hours. Scientists warn that if a similar or stronger event were to happen today, the consequences could be far worse. Satellites are another critical piece of infrastructure vulnerable to space weather. A single coronal mass ejection, CME, can disrupt communications, throw off GPS signals, and damage spacecraft electronics. In 2022, a relatively mild solar storm destroyed 40 newly launched Starlink satellites, costing millions of dollars in losses. If a major solar storm were to strike directly, it could take down large portions of the global satellite network, impacting telecommunications, internet services, and even military defense systems. Aviation is also at risk. High-frequency radio signals, which pilots and air traffic controllers rely on for communication, can be completely wiped out during intense solar flares. This is particularly dangerous for flights crossing polar regions, where exposure to solar radiation is greater. Airlines routinely reroute flights when major solar storms are predicted, but the disruption can still cause delays, increased fuel consumption, and additional costs for the aviation industry. Despite these risks, one of the most visually stunning effects of heightened solar activity is the appearance of auroras. During geomagnetic storms, these dazzling light displays can be seen much farther from the poles than usual. Already this year, auroras have been spotted in places as far south as New York and even Arizona, and during one extreme event, they were visible as far south as Puerto Rico. While these light shows are harmless, they are a vivid reminder of just how powerful solar storms can be. The worst-case scenario: a repeat of the Carrington event. In 1859, British astronomer Richard Carrington witnessed the most powerful solar storm in recorded history. Just hours after he observed a brilliant flare erupting from the sun's surface, a massive coronal mass ejection, CME, slammed into Earth. The results were catastrophic. Telegraph wires across Europe and North America caught fire, with some operators receiving electric shocks from their machines. Auroras lit up the night sky as far south as the Caribbean, so bright that people thought it was daytime at midnight. It was the most extreme geomagnetic storm ever recorded, and had it happened in the modern era, the damage would have been far worse. If a Carrington-level event struck today, it could trigger global power grid failures, leaving entire nations without electricity for weeks or even months. Satellites would be severely damaged, causing widespread disruptions to internet, GPS, and communication systems. The economic impact alone is estimated to be in the trillions of dollars, potentially leading to a collapse of essential services. The frightening part? We already had a close call. In July 2012, a Carrington-sized storm erupted from the sun, but missed Earth by just 9 days. Had its trajectory been slightly different, we would still be recovering from the damage today. The good news is that modern science has given us ways to prepare for extreme solar storms. NASA and NOAA operate satellites dedicated to monitoring the sun, including SOHO and the Solar Dynamics Observatory, SDO. These satellites provide real-time data on sunspot activity, allowing scientists to issue warnings days in advance if a major solar storm is inbound. Power companies have also taken steps to protect grids from geomagnetic surges by upgrading transformer shielding and installing emergency power reserves. Some governments have developed contingency plans for worst-case scenarios, ensuring that backup systems are in place if a Carrington-scale event were to occur. Spacecraft engineers now build satellites with better radiation shielding, and mission planners put satellites in safe mode when solar storms are predicted. Meanwhile, airlines continue to adjust flight routes to minimize radiation exposure for passengers and crew. While we cannot prevent solar storms, we can anticipate them and take action to minimize their impact. The sun's magnetic flip and the arrival of the solar maximum serve as powerful reminders that we are not just distant observers of our star, we are living within its vast, ever-changing atmosphere. Over the next year, solar activity will be at its peak, bringing an increase in solar storms, breathtaking auroras appearing in places where they are rarely seen, and the possibility of disruptions to power grids, satellites, and radio communications. Despite these challenges, modern science has equipped us with better tools than ever before to predict and mitigate the effects of space weather. Scientists, engineers, and space agencies are closely monitoring the sun's behavior, ensuring that we remain one step ahead of its most intense outbursts. The sun's magnetic field has flipped. The solar maximum is here. Earth now faces the full force of an active and unpredictable star. Thank you for exploring the universe with us on Space Observing Stations. If you enjoyed this cosmic journey, don't forget to leave a like, subscribe, and hit the notification bell to catch our future episodes. Keep looking beyond the horizon.